Today is the 26th of March 2024, and this will be our 14th video on trigonometry. Before I begin the lesson, thank you to everyone who have subscribed to our channel. Okay, thank you to the new subscribers as well. If you haven't considered it already, please can you consider subscribing, sharing, liking and following us. Okay, and sharing, like, nice comment, I will appreciate that. And if the account is not yours, ask permission from the account holder or ask somebody to help you open your account, okay, so that when we upload it, you get your own notification after you subscribed. Please follow my notes/script. You'll see it in the comment section when I upload. Okay, and all the videos have that, because maths is a lot of numbers. So for instance, this is tan theta equals O over A. O here is opposite, A is adjacent. Okay, so if you see that and I'm explaining, follow it. Okay, if you hear something else, follow it. This is 5.59. if you hear 559, add the point. Okay, please beware of scammers. Okay, they are everywhere. Beware of scammers. Okay, don't send you email and stuff under this platform. If you don't hear it in the video, don't assume. Don't send money to somewhere thinking, oh, I'm giving it to charity. It's not coming to me. Okay, please, we are not soliciting for funds here. Recap. Look at trigonometry questions. We are still doing trigonometry. Okay, I helped you learn how to use the formulas. So now we are just looking at trigonometry questions, and we said choosing the right function is important. Some of the questions, like we saw yesterday, you can choose tan, you can choose cos, you can choose sine, and you still arrive at the same answer. But some of them you have to go, if you have the opposite and adjacent, you have to go by tan. Okay, if you go by sine, you are going to get a wrong answer. Okay, and the right formula as well. Now, I started today because we are doing a lot of trick questions. I'm just putting in a lot of trick questions so that we can do as much as we can. So we start with trick, and then we end today's video with tricks as well, more trick questions. So here is the first diagram. Okay, it's a ladder and a wall. So that is your ladder there, and that is the wall. So a ladder must be inclined between 70 to 80 degrees on ground. So that is your ground. This angle should be between 70 to 80 degrees as shown. Okay, is this safe? So to find, you need to find this angle here, and you know the adjacent and you know the opposite. So if you find this angle and it's less than 70 or more than 80, then it's not safe. Okay, but if it's between 70 and 80, then it is safe. Okay, so let's see how we do this. Okay, so now tan of this angle, which I've said is theta, is the opposite over adjacent. The opposite here is 5.59 meters, the adjacent is 1.5 meters. Okay, so if you use the calculator properly, you are going to get 3.7267. that will be your tan. So the angle will be the tan inverse of 3.7267, which will give you the angle of 74.98 or 75. Okay, so here now it means it's safe because the angle is between 70 to 80 degrees. So an angle of 75 degrees, it will be safe with an opposite up to a height, okay, of 5.5 meters and away from the wall of 1.5 meters. Okay, now so let's continue. Now a second ladder was replaced with the first. So this is the first part of the question, and now they've replaced with the second ladder. Find what distance it should be from the wall to be safe. Okay, so we know that if it has to be safe, okay, it should be between 70 to 80 degrees. The angle you incline it. Okay, now the ladder, the second ladder, that assuming maybe you use the first ladder and the owner came for you, had to borrow a second ladder. This ladder is 4 meters. So they're asking you what distance from the wall to the ground should you incline it so that it will be safe. Okay, now we know that the minimum safety distance should be 70 degrees. The maximum safety distance should be 80 degrees. Okay, so we know the adjacent, we know the hypotenuse here. Okay, so cos 80, so I'm going to use the maximum. If it goes beyond 80, it's not safe. If it goes below 70, it's not safe. So I'd rather use the maximum, because if I use 70, then up to 80, what happens with that? So cos 80 will be the distance we want. That is the maximum distance you can fit it at, divided by the 4 meters of the length of the ladder. So here again, we need to apply the right function. So x will be 4 cos 80. Cos 80 on the calculator will be 4 times 0.1736, which will give you 0.69. Okay, so x here should be 0.69 meters to 2 decimal place, or 0.7 meters to 1 decimal place. If they don't ask you to leave it in any decimal place, okay, any of this is right. But assuming they restrict you, then you go by what, maybe 1 decimal place, then you go by 0.7. Now today we are going to look at more trig questions. Okay, we need to solve this to solve the next question, so I hope you understand. So this is also a right angle triangle, okay, and they are not to scale. So PQ is 5 centimeters, PR is 10 centimeters. Now the question says find QR, so we are finding this distance here. Okay, so now because we are finding this, we are going to use Pythagoras. There is no angle involved here. So the hypotenuse is 10 centimeters, all squared equals 5 centimeters all squared plus RQ or QR, what we want, all squared. Okay, so QR or RQ all squared will be 10 all squared minus 5 all squared, because if this 5 all squared moves to the left hand side so that we can make QR all squared the subject, then it's going to subtract because it's adding here. 10 squared will be 100, 5 squared will be 25, so we have 25. QR now all squared, if you want QR, will be plus or minus square root of 75. Okay, we can leave our answer as square root, or if it's a calculator, if they ask us to, then we can do that. They can ask you, leave your answer as a square root. Okay, so the square root of 75 can be written as 25 times 3. So the root of 25 will be a 5. Okay, and the root of 3 will be, so it will be 5 root 3, sorry. So it will be 5 root 3 centimeters. Okay, so you can leave your answer as 5 root 3 or 8.7 centimeters to 1 decimal place, or 9 centimeters as the whole number. Here, root of 25 is 5. Okay, so the 5 is out, and then you have root 3, not the other way around. That is said here. So you can leave your answer as 5 root 3 or 9 centimeters to the nearest whole number, or 1 decimal place. Okay, so this QR will be any of these answers. Okay, remember your units. Now let's go to the next question. So here you are again. Calculate the angle QPR from the first question we just did. Okay, so here QPR, so it's the angle at P here. Okay, now we just solved QR, which we found the answer to one whole number as 9 centimeters, and we put the answer also inside. Okay, so here we know the hypotenuse, we know the adjacent. Okay, and we are supposed to find this, so we can use TOA, or we can use sine, or we can use cosine. Okay, or we can use tan, because we've just solved for this part here. Okay, so I'm going to use the original figures and use cosine. So the cos of this angle at P will be adjacent, which is 5, divided by the hypotenuse, which I've done here. 5 over 10, the hypotenuse is 10, which is half, which will give me 0.5. So cos of the angle at P here will be cos inverse of 0.5. And if you do that on the calculator, you get 60 degrees. So this angle is 60 degrees. Okay. If you want to use the QR you found, you've converted it to 1 decimal place. Okay. So it's not exact. And we have the 2 decimal place. So you can either use the said 5√3, okay, which will give you the accurate figure, or root of 75. But if you use a conversion, it will be less than 9, because this is to 1 decimal place. Okay. So you can use the tan inverse or the sine inverse. They will give you answers close to 60 degrees. Okay. But because they've given me these figures, I want to use their figures to give me accurate figures as much as possible. Now, the B part, okay, which is a bit tricky. Look at the diagram carefully. Okay, so using your answer from I and II. So what we get, so this is the I diagram, the triangle that we found QR, 5 centimeters and 10 centimeters. Okay, calculate the area BXC. This one BXC. AB is 10 centimeters. These diagrams are not to scale. AD is 5 centimeters. An arc of a circle of radius 10 centimeters with center A. Okay. So this is the arc they've drawn here. I drew it. Okay. The arc. So they've drawn an arc there. Okay. The arc starts at B and meets at the side CD. So this is the triangle, rectangle. So they've drawn an arc here. Okay. Arc has to do with circle. We did videos on that. And then to cut. So it's not like a straight line, it's an arc. And the radius is 10 centimeters. Okay. Now, they want us to use the first 2 questions we solve to solve this. Look at this triangle carefully. Okay. If you invert it, okay, you keep it upright. This BQ is 5 centimeters, which is this side. Okay, so even though they've given A, B, C, C, D, okay, I've come to fit this triangle in this diagram here. So from the first part, PQR, okay, is where we found this angle to be 60. Okay, and this side was root of 75. Okay, so now this is our first triangle, and that is an arc, and that is also an arc. Okay, so ADB. So if I fit this triangle in here and I put in this thing, so PQ, this is PQ, and this side is 5 centimeters, so that side is 5 centimeters. We found QR to be root of 75, yeah, and that side is 10 centimeters, PR, which is PR here. So assuming I fit this in here, okay, and I can find this area, then I can find the area of the whole rectangle, subtract this area and this area, and what will be left will be this area that I need to find. Okay, so now let's get on if you understand what I've explained. So look at the diagram carefully. Okay, so I'm going to find this area here. This is a triangle, so it will be half base times the height. So here, half base, our base is root of 75, okay, times the height, which is 5, okay, there. Okay, now this is 5 over 2, which is 2.5. Okay, so this actually is not, so root of 75 times 5 over 2, which will become 2.5. Okay, will give me, root of 75 will give me 8.66, okay, times 2.5, so it will be 21.65 centimeters squared. That will be this area here. Now we need to find this area. Remember, they've told you it's an arc. So if this angle that we found is 60 from the first part of the second part of the question here, because if I fit this triangle in there, this is a right angle triangle, this is a corner of a rectangle. So if this is 90 and this is 60, then that is 30. To find the area of an arc is pi, your angle, 2 pi r, your angle over 360. We've done this on the video. So we found this area 1. We need to find this area. So the area of the arc here, the angle is 30 to make it 90. Divided by 360 here, then pi r squared. Okay, assuming it was just a circle, it would be pi r squared, but because it's a sector and an angle is involved, we need to divide the angle over 360. So 30 over 360 pi r squared. Okay, so 30 over 360 here, we take the 0 off, 3, 1, how many 3's we have in 36? 12. 10 squared is 100, because the radius here is 100, is 10 from, they've told us in the question here, with radius here. An arc of circle with radius 10 centimeters with center A. Okay, that is the center A. So if you are here, you draw an arc like that with a compass or anything, that will be your radius 10 centimeters to form the arc. So 10 centimeters here, all squared, because we're using pi theta over 360, pi r squared. Okay, so now we have 1/1200 pi. Now if you do this correctly on the calculator, so 100 over 12 times pi will give you 26.18 centimeters squared to 2 decimal places. So this will be the angle here. Okay, now the angle of the whole rectangle is 10 times 5. Okay, assuming we include this part. So that will be 50 centimeters squared. So now, the third part, we are finding the angle of the rectangle, which is 10 times 5, the full rectangle, the full shape. Okay, that's 50 centimeters squared. So now, we know the angle of this whole rectangle. Okay, we use this one to find the area of this part using half base times height. Okay, this part here, okay, we use this angle. If this is 60, which we found from the second part of the equation, then that will be 30. So we have 30 over 360, okay, times pi times the radius of 10 centimeters all squared, because it's pi r squared theta over 360. Here our theta is 360. So we found this area. We found this area. And we found the area of the whole rectangle, which is 5 times 10 centimeters. So to find this area here, we have 5 times 10 centimeters, which is 50 centimeters squared, minus the area that we found for the triangle, minus the area that we found for the arc, which will give us this area here. Whatever is left is this area here. Okay, so let's go on. So the area of the rectangle here is 50 centimeters squared, minus the area of the triangle, and then minus the area of the arc. Okay, the area of the triangle, 21.65 centimeters squared, minus 26.18 centimeters squared. This is centimeters squared, not centimeters. Area is always the unit squared. So if you subtract, the shaded area becomes 2.17 centimeters squared to 2 decimal places. 2.2 centimeters squared to 1 decimal place, or 2 centimeters all squared to the nearest whole number. Okay. So this is what I came to show you today. This diagram, they just said apply what you did previously. So I had to fit in there. So I had to do this and separate this from this. Without that, you can't solve that. So you need to see the first part. And even because they've made it A, B, C, D, I had to put this P, Q, R in here. So I put P on top of the A, Q on top of underneath the D, and then R, for me to be able to use what I did in the first two parts. Okay, so it's just shifting the diagram. This is the right angle triangle, which is here. Okay, so if you understand that, then you can use what you did at the first part to find the area here, which is half base times height. And then with the angle you found, this is 90, so this is 30 then, and a radius of 10 centimeters, which you've been given. Then you use the angle to theta over 360, pi r squared, r is your radius, to find this area. And then you find the area of the rectangle, which is 5 times 10. You subtract this area and this area from the rectangle, and what is left is BCX, which we found here as 2 centimeters all squared to the nearest whole number. Okay, so I hope if you don't understand, just go back and have a watch, please. Okay, can we subscribe, please? Like, share, follow. And if you need to open an account, ask somebody to help you open the account. If you are using somebody's account, ask for permission. Follow my notes/script, please. Beware of scammers. Take care of yourself online. Thank you for watching today's video with me, and I'll see you in the next.